So in this series, we're going to be talking about ketones and aldehydes. Now, what are they? Well, they're a derivative of a carbonyl, and I just want to explain what a carbonyl is first. So I suppose I'll go right in here to start off this lesson. A carbonyl is an oxygen bound to a carbon, and there's some groups off to the side. So we'll call this Z and Z, right? Just random groups, could be H's, could be carbon groups. Now, ketones, some activity that they have, for example, is having a resonance form where we push the pi electrons up to the oxygen, and this becomes slightly negative, and the carbon is slightly positive. What we'll see in the next videos is that that carbon is especially weak, and we can attack it with nucleophiles. So let me grab an eraser here, just ignore that. But basically, yeah, this whole chapter is going to be on that idea of the carbonyl, a double bonded carbon. So the two that we'll be looking at in this chapter, really before carboxylic derivatives, is ketones and aldehydes. Now, a ketone has two R groups on it. That means two carbon groups. For example, we have this molecule here, 2-butanone. We'll get to the naming in a second. But notice how there's a methyl group to the one side and an ethyl to the other side. Butanol, for example, is an example of an aldehyde. That's where you have one carbon group and one H. Notice how here we have a propyl group to the one side and we have hydrogen on the other side. Now the naming, the IUPAC rule for a ketone is drop the E, add -one. So in this case, we have butane, so I'll actually reverse it here. We have butane, okay? We have a carbonyl in the second spot, so we put 2-. Butane, drop the E, -one, right? That's that rule there. For aldehydes, it's the same thing, but instead of -one, it's al, A-L. And we don't have to really give position. I mean, we can. If we really want to, we can say 1-butanol. But notice here it's butane, we drop the E, we add the AL. So now that we know how to name ketones and aldehydes, let's go through some priority, because priority in naming is quite important. So the highest priority functional group we know to be a carboxylic acid. I have some other examples like an acid halide. Yeah, acid halide, geez, I don't know why that was so hard. And then we have a nitrile. Below nitriles are aldehydes and then ketones. So notice that the ketone is higher than, the aldehyde is higher than the ketone. So when we name, we need to make sure that if we have both, that we name the aldehyde as the parent chain, if applicable. Below that would be like hydroxyl groups and amines. It's not the highest priority group, but they're right below the benzene derivatives. So let's move on here to some examples in naming. We have a pentane here. We have a pentane parent. I want you to name all of these. So we have a pentane parent. We can reach this carbonyl fastest if we go which way? 1, 2, 3, 1, 2, 3. So it doesn't matter if we go left or right. We want to also reach our hydroxy group first, so we're going to go from the right to the left. We have a hydroxyl group in the second spot, so we call this 2-hydroxy. And we have 5 carbons, so that's pentane. We're going to drop the E and add -one, but notice we forgot to, and this is on my bad, we forgot to name the carbonyl. So we need to say that it's in the third spot, pentanone. Alrighty, so 2-hydroxy, 3-pentanone. That's that molecule there. Now let's go to the one to the right there, that cyclohexane ring. Notice how we have a aldehyde here. This actually gets a special name. So in this case, you name the parent and then you add carbaldehyde, right? So anytime you have a ring as a parent and you have one carbon and then an aldehyde, you name that a carbaldehyde. So the way we want to name this is we don't want to go this way, we want to go the other way as to reach hydroxy first. because hydroxy is more than a halide group. So we're gonna go 1, 2, 3, 4, 5. So this is 5 chloro, 3 hydroxy, cyclohexane carbaldehyde. So that's what that is, and you don't drop the E, double consonant rule there with IUPAC. So cyclohexane carbaldehyde, it's kind of a mouthful and kind of a strange choice on their end. Now let's get to when you have an aldehyde and a ketone. This is important here because you need to say al and one. That's kind of weird, isn't it? So they made it a little easy. Anytime you have a carbonyl and you have an aldehyde, you name the carbonyls inside the structure or the ketones as oxos. OXO, like the kitchenware, right? OXO. So we're gonna name it starting 1, 2, 3, 4. This is butane. We say 2-oxo, and we don't need a dash. Butane, drop the E, add a L. So this is 2-oxobutanol. Now what if we have, like, for example, 3 ketones? Well, how do we name this? Pretty simple. Since there's symmetry, it doesn't matter which way we go. So we'll go 1, 2, 3, 4, 5. So we'll say 1, 3, 5. You need to go 1, 2, 3, and then it's cyclohexane. Drop the E, add one, but signify that, so you're saying 1, 2, 3, 4, or 1, 3, 5 cyclohexane one. So this tells you that there's a cyclohexane ring, and coming off of 1, 3, 5, there's respective carbonyls there. Or sorry, we would say cyclohexane trione. So that's how we name that.